Hi, welcome back. Today we'll see about Hadoop cluster. So Hadoop cluster specifications. As we know, Hadoop is a distributed system which has collection of multiple nodes. It's a name node and data nodes. All these together form a Hadoop cluster. So we'll see what are all the cluster specifications that we need to take care while installing an Hadoop system. So the following factors are mainly considered when creating a Hadoop cluster. First one is the node types, second CPU, RAM, disk space, network connectivity, high availability, scalability, and consideration of Hadoop ecosystem. Now we'll see each and every single item individually to understand the Hadoop cluster requirements. Node types. So majorly in Hadoop system, we have two nodes, master node and the worker nodes. Now we'll see in detail. These nodes host the name node, resource manager and other central services. The master nodes host the name node, resource manager and central services. They require higher computer power, memory and disk capacity when compared to the worker nodes. So as we see, two types of nodes, master node and worker node. The master node needs more computational power when compared to the worker nodes. Now we'll see worker nodes. These nodes run data nodes, node managers and perform data processing tasks. They typically require a balance of computer power, memory and storage based on the data that has been processed with the worker nodes. So these are two types of nodes, master nodes and worker nodes. In simple terms, generally people call name node as a master and data node as a client or worker node. Now we'll see the CPU. The number of CPU cores affects the parallel processing capability of your cluster. That is, if the CPU has more number of cores, then it will be able to perform parallel processing in the cluster. Considering the number and complexity of the task you expect to run simultaneously and allocate an appropriate number of CPU cores per node. So this is where the speed of the system depends. The other one is RAM. Allocate sufficient memory to each node based on the size of data you will be processing and the complexity of your computation. So depending on the number of nodes, the data size and also the complexity of your computations, you need to allocate sufficient memory to the system. More memory allows for a larger data sets to be held in memory, reducing disk input and output operations. That is, if it have large memory allocated to the system, it can hold large data in memory, which directly reduces the data transfer between memory and the hard disk storage devices. Disk space. Hadoop relies on distributed storage, that is a HDFS, and each node requires local disk space to store data blocks. So whenever the data in Hadoop is being transferred, it uses both the local hard disk and also HDFS file system. Determine the total amount of storage needed based on your data size and replication factor. So the storage depends on the data size that you are maintaining in your Hadoop cluster and also the replication factor. So as we know, replication factor is the redundant copy maintenance in the cluster. SSDs can offer better performance than traditional hard disk drives. Okay, so next one is network connectivity. Nodes in a Hadoop cluster need to communicate with each other efficiently. In a cluster that is formed by a network, it needs continuous and proper communication between the nodes. Ensure that your network infrastructure provides high bandwidth and low latency to minimize data transfer times. If you have a good bandwidth and low latency, the data transfer between nodes will be done in shorter amount of time. high availability. For production environments, consider implementing high availability features such as redundant master nodes and fault-tolerant network setups to ensure continuous operation in case of node failures. So for high availability, you need to maintain redundant master nodes. That is, if a master node fails, the another should be available to back up the system. And the fault-tolerant network setups. If one network failures, the other shall be able to restore the network and keep continuous communication between the nodes. Scalability. A plan for future growth by designing a scalable architecture. That is, the system should be able to scale up the resources when there is a demand of the resources. Consider the ability to add more nodes to the cluster easily and ensure that your hardware and networking infrastructure can accommodate your expansion. So this is where the scalability matters. Next, consideration of Hadoop ecosystem. If you plan to use Hadoop ecosystem, components like Hive, Spark or HBase take into account their resource requirements and ensure that your cluster specification can support them. That is, if you are working along with MapReduce and HDFS, if you want to plan working with Hive, Spark or HBase, which are part of Hadoop ecosystem, then you need to take care of the resource requirements and if your cluster meets the resources or not. Now, Hadoop cluster setup and installation. First, we need to prepare the environment, download the Hadoop latest version, configure secure shell, set up configuration files, configure nodes, format HDFS, start Hadoop services, verify the cluster setup and test the cluster. So these are various steps that need to be taken care in setting up of a Hadoop cluster. First, prepare the environment. That is, decide the base operating system we need to maintain. Choose a Linux distribution that is compatible with Hadoop, such as Ubuntu or CentOS. Set up a network with proper connectivity among the cluster nodes. Ensure that JDK, Java Development Kit, is installed on all the available nodes in the cluster. Now, you need to download Hadoop. Visit the Apache Hadoop website and navigate to the download section. Download the desired version of Hadoop, which is latest. You can choose between stable releases or newer versions depending on your requirements. And the next step is configure secure shell. So this is the first and major step that is to be configured in the setup of Hadoop cluster. Set up SSH communication between all the nodes in the cluster. So you need to generate SSH key pairs and distribute the public key to all the nodes, allowing passwordless SSH authentication. So this is now set up configuration files. Extract the downloaded Hadoop package on all nodes of the cluster. Navigate to the Hadoop configuration directory. So this is the Hadoop name home /etc/Hadoop. So Hadoop home refers where exactly you have downloaded and extracted the Hadoop system. Modify the following configuration files based on your cluster setup. So you need to modify some files before running the cluster. The first one is a core site XML file. It set properties for Hadoop core such as the file system, default name and IO settings. Next one is HDFS site.xml. Here you need to configure the HDFS properties including the replication factor and also the block size. That is, if you want to go with replication factor 3 or 4, you need to configure, and then the block size like 512 MB or 1 GB or 256 MB based on your requirement. And the next one is a yarn site XML. This is to configure the yarn resource manager and the node manager settings. And then mapred-site.xml. Customize the MapReduce framework settings. So these are some important files that you need to configure in Hadoop setup. Next, configure the nodes. Identify the master nodes and worker nodes in your cluster. So edit the masters file to specify the hostname or IP address of the master node. Edit the slaves file to to list the host names or IP address of the worker nodes. So this is where you will set up the name nodes and data nodes are called as master and slaves. Next, format HDFS. On the master node, run the command HDFS name node -format to format the HDFS file system. So on the local disk, once you perform the execution of this command, it formats the hard disk into HDFS format. So the Hadoop distributed file system where exactly the data is be stored. This command initializes the name node and prepares it for use. Next, you need to start some Hadoop services to run the Hadoop distributed system. On the master node, start the Hadoop services using the command start-all.sh. So if you run this start-all.sh command, it will start all the required resources like name node, data node, resource manager, node manager, and the other required services. So this will do the starting of all these services. Next, verify the cluster setup. Access the Hadoop web interface to ensure that the cluster is running correctly. So open a web browser and visit the following URL. So this is the default URL to check if the Hadoop cluster is up and running. So this is the port number which you need to give mandatorily to see the web version of the name node. To see the resource manager, if it is running, you need to click HTTP master node -AJW. Here it refers as a maybe a local host can be used or IP address of the system can be used to see if these services are up and running. Check the status and health of the Hadoop cluster through these interfaces. Next, test the cluster. Run a sample Hadoop job or test data processing task to ensure that the cluster is functioning as expected. You can use the Hadoop-examples.jar file provided with the Hadoop distribution to run sample jobs. So this will contain some sample jobs which is helpful to see if your cluster is up and running. So see some of the files. Configure general Hadoop properties including file system settings and IO settings in the core-site.xml file. Next, HDFS site.xml. It's customizes Hadoop distributed file system settings such as replication factor, block size, and also specifying the storage directories. Yarn-site.xml. It will configure the yarn resources manager and node manager settings including memory allocation, scheduling policies, and also log aggregation. Next, map-reduce-site.xml. It customizes map-reduce framework settings such as the number of map and reduce slots, speculative execution, and also task timeout. Next, Hadoop env.sh. It sets the environment variables for a system. It environment variables like Java home and Hadoop specific parameters. So it is for setting up the environment. Next one is Hadoop metrics.properties. It configures metrics reporting for monitoring Hadoop cluster performance. So this will help you to monitor the cluster performance, whether it is up and running or it is facing any issues. Next, capacity scheduler.xml. It will help fine-tune resource allocation and scheduling policies in a multi-tenant environment. If you have more number of name nodes and data nodes, this will help you to clearly scheduling the policies and perform resource allocation. Now, security matters. Authentication. Implement authentication mechanisms to verify the identity of users and services accessing the cluster. Hadoop supports Kerberos for secure authentication. So you need to focus on who are trying to access your cluster. So by using Kerberos, the Hadoop maintains security to see whether the requested user is genuine or not. Authorization. Set up access control policies using Hadoop access control list, that's ACLs, to determine who has read, write, and executed permissions on files and directories in the Hadoop system. This will keep record of the data who has made some modifications or was trying to read the data in the system. Encryption. It enables encryption for data in transit and at rest to protect sensitive information. So it will make you to encrypt the data that is in transit between different nodes and also at rest to protect important and sensitive information. Hadoop supports both SSLs and TLS encryption for secure communication between nodes and encryption of data stored in HDFS. So HDFS supports both the SSL and TLS methods of encryption. Next, firewall and network security. Implement firewall rules and network security measures to restrict access to the cluster from external networks, controlling incoming and outgoing network traffic using appropriate network configurations. That is, it monitors the input and output data to see if it is secure or not. Secure configuration. It hardens the cluster by disabling unnecessary services, enabling secure communication protocols, and regularly patching and updating the Hadoop software. So whenever Hadoop gets updated in the internet, the secure configuration will take care of updating the regular patches and keeping the Hadoop software up to date to meet the secure configurations. Auditing and monitoring. Set up auditing and monitoring tools to track user activities, detect suspicious behavior, and ensure compliance with security policies. So this auditing and monitoring will help you to take care of the user activities, track which user is performing what kind of task, and check if there occurs any suspicious behavior from any user and ensure compliance with security policies. Now, administering Hadoop. Monitoring and health checking, capacity planning and storage management, data replication and block management, data backup and disaster recovery, maintenance and upgrades, and troubleshooting and issue resolution. See, monitoring and health checking. Regularly monitor the health of your HDFS cluster using tools like Hadoop's web interfaces such as the name node and data node user interfaces to check the status of nodes, block distribution, and overall cluster health. So as we see earlier, we can access name node web interface. Using that web interface, you can check the status of all the nodes, block distribution, and overall cluster health. Next, configure and enable Hadoop metrics to collect data on cluster performance, usage, and resource utilization. Utilize monitoring systems or tools like Apache Ambari, Cloudera Manager, or Hortonworks data platform to gain deeper insights into health and performance of the HDFS cluster. So using these tools like Apache Ambari, Cloudera Manager, or Hortonworks DP, you can get deeper insights and check the performance and health of the HDFS cluster. Next, capacity planning and storage management. You plan the storage capacity requirements based on your data size, replication factor, and the sudden expected growth of the cluster. So based on this, you need to plan the storage capacity requirements. Next, regularly monitor and manage available storage space to prevent overloading or running out of disk space. So you need to constantly monitor the usage of the data and see if there is unnecessary data. You need to remove that and avoid overloading or running out of disk space issues that may occur. Consider implementing Hadoop's HDFS quotas to enforce storage limits for users or directories. So you can enforce quota management system to restrict users or directories to use the data based on the storage limits that you may decide. Data replication and block management. Here you can configure the replication factor based on fault tolerance requirements and the number of data nodes in the cluster. So based on the availability of data nodes in the cluster, you can decide the replication factor. Monitor and manage block reports to ensure the correct replication factor is maintained and missing blocks are identified and recovered. So constantly you need to check if there are any missing blocks and you need to recover them and maintain replication factor. Manage block placement policies to optimize data locality and minimize network traffic. This is an important thing where you need to focus more. So data replication shall be placed in a way that it is available very locally and also that minimizes network traffic. Data backup and data disaster recovery. Establish regular backup procedures to protect against data loss or corruption. This can involve taking periodic snapshots, replicating data to offset locations, or implementing backup solutions such as Apache Hadoop Backup and Disaster Recovery. This is a BDR, Backup and Disaster Recovery Tool, or Apache Hadoop Distributed File System High Availability. This is a HFS HA. So these are the both two tools that help you for backup solutions in the HDFS system. Define and document disaster recovery plans, including procedures for recovering the HDFS cluster in the event of failures or catastrophic events. That is, if a small failure occur or a big disaster occurs, you need to document how the disaster recovery plans can be taken care to retrieve the data and restart the HDFS cluster without any issues. Maintenance and upgrades. Schedule regular maintenance activities such as checking for and applying software patches, upgrading Hadoop versions, and performing hardware maintenance tasks. So these need to be taken care regularly. Plan for coordinate downtime, ensuring minimal disruption to the cluster's availability and data access. If you need to down the system and restart, then you have to ensure that there will be minimal disruption to the cluster's availability and also for data access. Now test upgrades and changes in a non-production environment. So this is very important when you perform security patches or upgrading Hadoop versions. You cannot directly test it on the production environment. So first you need to test on non-production environment and then roll out it onto the production cluster. Troubleshooting and issue resolution. Monitor and analyze the log files. So this is very important task. Constantly you need to monitor the log files to check if there are any issues, including the name node and data node logs to troubleshoot issues and diagnose failures. So if you continuously keep monitoring the log files, you can avoid many issues. Utilize Hadoop's built-in command tools like HDFS FSCK, HDFS DFS admin, HDFS balancer. These are our command line tools which will help for diagnosing and resolving data inconsistencies, block or storage issues, and also overall cluster problems. So using these commands you can diagnose the issues. Monitoring and maintenance. What exactly it does? Administering Hadoop involves monitoring the cluster's performance, health and resource utilization, as well as performing regular maintenance tasks to ensure its smooth operation. So monitoring tools and techniques, performance optimization, capacity planning and scalability, regular maintenance tasks, issue resolution and troubleshooting. Here in monitoring tools and techniques, we have name node UI. There is a built-in web interface, resource manager UI and job tracker UI to monitor the cluster health, status and resource uses. So these three user interfaces helps us to monitor the cluster health. Next, leverage monitoring system tools like Apache Ambari, Cloudera Manager or Hortonworks data platform to gain more comprehensive insights into cluster metrics, alerting and performance analysis. So along with these user interfaces, you can also use these additional tools to get more insights and study the cluster metrics. Configure Hadoop's metric subsystem using Ganglia, Graphite or Prometheus. These are some tools which help to check the Hadoop's metrics. This helps to collect and visualize metrics on various aspects of the cluster, including CPU usage, memory, disk, network, and job execution statistics. Implement logging and log aggregation mechanisms, that is using Apache Log4j or ELK stack. This helps to maintain logs in the system. To centralize and analyze logs from Hadoop services for troubleshooting and performance analysis. Performance optimization. Regularly analyze cluster metrics and identify performance bottlenecks or resource hotspots. So you need to continuously check the cluster metrics to identify performance bottlenecks if may occur or resource hotspots that are using the available resources. Tune Hadoop configurations such as block size, memory allocation, parallelism settings and input-output buffers to optimize performance for specific workloads. So based on specific workloads, you can update the block sizes, memory allocations, and parallel settings. Next, monitor and adjust resource allocation policies. Example, yarn queue configurations to ensure fair sharing of cluster resources among different users or applications. So this will help proper utilization of resources among different available users. Consider using workload management tools like Apache Uzi or Apache Ambari used to manage and optimize job scheduling, dependencies, and resource uses. Next, capacity planning and scalability. Monitor resource utilization, storage capacity, and workload trends to forecast future requirements and plan for cluster expansion. Next, analyze historical data on job execution, data growth, and user patterns to estimate future resource needs. So this helps us to plan for future requirements if we need to improve or increase the resources into the cluster. So based on this patterns, you can identify the future requirements. Scale the cluster by adding more nodes, increasing storage capacity, or adjusting resource allocation based on capacity planning and growth projection. So based on the available patterns you have identified, you can do the addition of storage space, or you can even add additional nodes to the cluster and adjust resource allocation based on capacity planning and growth projections. Regular maintenance tasks. So you need to schedule regular maintenance activities, including applying software updates or patches and security fixes to keep the cluster up to date, avoiding major issues or failures. Monitor hardware health, including disk status, network connectivity, and server temperature, and perform preventive maintenance or replace faulty components whenever necessary. Next, implement backup and disaster recovery mechanisms to protect against data loss or corruption, including taking regular snapshots, replicating data, or utilizing backup solutions specific to your Hadoop distribution. This will help to retrieve or restore data when there is any catastrophic failure occurred in the Hadoop system. Issue resolution and troubleshooting. Stay vigilant for alerts or notification from monitoring systems, logs, and error messages that indicate potential issues. So if you continuously monitor logs available in the system, you can avoid major issues. So when you continuously monitor the logs and perform the specific alerts, you can keep your cluster up and running. Perform root cause analysis of failures or performance degradations by examining logs, metrics, and system behavior. Here you need to check out the root cause to resolve the issue. Utilize Hadoop's command line tools such as HDFS, FSCK, yarn application status, MapReduce, job status for diagnosing and resolving specific issues related to HDFS, yarn, or MapReduce. So study by using these available command line tools, you can analyze whether the system is running perfectly or not. Engage with Hadoop community forums, mailing lists, or support channels to seek assistance and advice from experienced users and experts. So this Hadoop community forum will help you to keep update yourself with the latest trends and technologies that help you to keep your Hadoop cluster up and running. So this is the cluster setup of Hadoop. You can see how a Hadoop cluster can be set up and maintained without facing any issues. Thank you.